What's up, guys? Welcome to the next video in learning C++. My name is QD Danny, and you guys watching my channel Corawood. And in this video we're gonna see the algorithms, the mighty algorithm. All right, algorithms. All right. So if you guys never heard of these algorithms, what is algorithm? Algorithms is in everyday life, we do algorithms all the time. So we wake up, we go to wash our face, and then we go for shower. If you guys do shower, then we go for breakfast, we make coffee, and then we go to school, our work, our anywhere else, if you got appointment or somewhere. That's algorithms. So if another example of algorithms is you guys go to library, you guys looking for your favorite book, and your favorite book says all A, B, C, or fiction or non-fiction or scientific or whatever books in the world you guys interested in. So you guys gonna go, either you guys go aisle by aisle, or you guys go like A, B, C, or you guys going through the categories of fiction, non-fiction. But if you guys going to aisle by aisle, and if you are in big super library with say hundreds of aisle, then God knows how long it's going to take for you to look for your book, because you guys might go through this fiction, non-fiction, scientific. You guys may be running to computer books, and maybe in scientific books, or God knows any other religious books, or blah 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 books. All right, so it's gonna take you ages, and good luck if you guys gonna go by aisle by aisle. But otherwise, if you guys say even the worst one is if you guys gonna go in looking for your books, book by book inside the library with the millions and billions of books. All right, so another one is if you guys go in looking inside the category of your book. So this is called algorithms. So how long it takes you to find your book, how long it takes you to find your desired book. Or say another example of algorithm, say you guys going from airport to home. So if you guys can decide which way to take. Either you guys gonna take the taxi and then sit in the bus, go to home, or you guys want to sit in the taxi and straight home, or you guys going to take the bus all the way to say terminal, the train, then you go to your suburb or wherever you live. So this is algorithm. So this is up to you which way you decide to go. Even in the restaurants, you go say the algorithms of the restaurant, that's how it works. You go and sit there, the waiter or waitress comes in with the menu and taking order from you, and you guys order. Another algorithm is that you go to the buffet and you guys choose from the buffet, you guys choose soup, and then you guys choose your main, and then you guys go for dessert. So this is algorithms. It goes like step by step in order. So this is algorithms. Algorithms very powerful and very easy. So how we use, why we need the algorithms in computers. So you already learning, say you guys might say I'm learning C++ or Python or Java. All right, according to Stanford and MIT professors, if you want to be programmer, just write code for 2 years and you're a programmer. So you want to be the best programmer, you put this 2, put another 2 on top, make it 4 years, you're the best programmer. But if you want to be the best programmer in the world, you guys learn this algorithm. So you guys take the class of algorithms, and you guys gonna be, so with the 2 years of programming plus algorithm is equal to best programmer in the world. All right, so this is a definition of algorithm. So now we define algorithms in according to the computer science. So in algorithm we have two basic categories. So one is to analyze the algorithm, and another one's to design the algorithm. So designing is first we go with analyzing, because that's the difficult part, and designing is the next step when you guys become master in analyzing algorithm. So to analyze algorithm is to measure and describe its performance. So we see how fast or how better time wise it goes. If you understand how well algorithm performs, indicates whether algorithm is practical given the resources that are available. Algorithm analysis provides a basis for comparing different algorithmic solutions to the same problem, ranking them by performance and identifying which are most efficient. So we're looking for the most efficient algorithm, and we say how long it takes to algorithms to finish one task. So algorithms analysis generally concentrate on the resources of space and time required by algorithm. So this is a definition of computer algorithms, and in this video we're gonna say simplest algorithm, which is the bubble sort. So bubble, you guys might hear this bubble. Oh my god, bubble, bubbly bubble. Not that bubbly bubble, that's it's a bubble sort. The name came in after the it's like a soft drink, the bubbles goes up. So our some programmers call it sinking algorithm. So to analyze algorithms, we must first identify the operations it uses and what each one cost. So we're looking for the cost as well, and this is specified as a model of computation. Model of computation. So this is we're looking for the cost. Yeah. So I don't want to confuse you guys with this model of computation and with the cost, because I just wanted to mention that this is how the algorithm works, and we're looking for the time complexity as well. So how we measure the complexity, and we're looking for the time. So we go ahead and look inside this Wikipedia. So the simplest one, if you guys gonna go and study this http wikipedia.wiki.org/wiki/bubble sort, because I just wanted to do this because we're already doing arrays, and inside this array it's the best time for me to describe these algorithms, even though I'm intending to create another totally another series, another playlist with totally with algorithms. So I want to use the C++ and Python, but for this video, because I'm introducing algorithm to you guys, and I'm introducing this bubble sort, is sometimes referred to as sinking sort. It is a simple sorting algorithms. That's what we are going to do, because we're going to sort our array that repeatedly steps through the list, compares adjacent elements and swaps them if they are in the wrong order. Alright, so say if we've got inside our array we have say 2, we have a 5, we have a 8, we have a 9, and we have a 10, say, and we have a 3 here. Alright, so what the sorting algorithms they come and do, it iterates around, it comes and compares this 2 and 5. They say which one is bigger, which one is smaller, the 2, and it puts the 2 here, and then it says okay, 5 is bigger than 2, and it puts here. Then it goes to here, because I put it in order. So I'm gonna put it 9 here. I shouldn't put it in order, I'm gonna put it in different order, say 7 here. Then it goes and analyze this, because once this 2 is done, then it goes and checks this 2. It says which one is smaller. Then it says finds the 7. It brings the 7 here and brings the 9 there. Alright, so it compares this 10 and 3. It says which one is smaller. Says the 3 is smaller, so they put a 3 here and they put a 10 here. So this is one loop. it goes in loop again, and it comes in and find this 2 is okay, then it says this 2 is okay, then it says this 2 is okay, then it checks this one and it says this 2 is not okay. So the next one is going to put a 2, 5, 7. So checks 9 and 3, and it finds that the 3 is less than 9, so it puts the 3 here and checks the 9 and 10. It says okay, that's fine. And the next loop, it goes the loop again, then it says 2 and 5, okay, then it's put 7 and 3, which is not okay. 3 is less than 7, they put a 3, and then it's put a 7, and then put a 9, 10, 9 and say 10. Then it goes to the next loop. It traces again. It says 5 and 3. It says 5 and 3. It says 3 is less than 5. It goes here. Then it put a 5. Then it says 7. Then it says 9 and 10. Then it says that's fine. That's the last loop. It goes there. It says 2 and 3 is fine. 3 and 5 is okay. This one is okay. This one is okay. That's how it goes. So if I put them in order, so I'm gonna put it in order. All right, so if you see in order, that's how we see this. You see 5, 5, 5, then it says 3, and if you see this 9, it comes in order. So if you say 3, 3, 3, 3, say 3, 3, 3, say you guys see all these threes, it comes in order. So that's how it travels in interval all the way here. So that's how we describe this bubble sort. The bubble sort goes like that, like a stepwise. Say if you put any other number here, if you the number, then it goes stepwise. But because this number is already in sorted order, I put it on already in sorted order. That's how it's already okay. So if you see like this straight, it means that the number is fine. It's not in sorted. But this 3 is because we sorted 3 all the way here. That's how it is. But if you guys want to try with different one, then you're gonna see the step here. So you're gonna see step of 4, step of 3, step of whatever numbers you guys sorting. So this is bubble sort. And if you look inside this Wikipedia, if you guys looking the same as I was explaining, it's comparing 3 and 1. It puts the swapped 1 here and 3 here, then checks 3 and 5, then it says okay, 5 and 6 okay, then it checks 2 and 6, and then it moves the 2 here, then it checks 6 and 4, then it moves the 4 here, then it goes to 7 and 8, which is 6, 7 and 8, which is fine. Then it goes another iteration, another loop. So it goes 3 and 5 fine, 2 and 5 it's not okay, so they put a swap the 2 and 5 here. Then it goes 4 and 5, 5 and 4, and says it's not okay, bring it here, and it's because this is okay all the way fine, it leaves this alone. So it goes to 1, 3 okay, 2 and 3 is not okay, it brings it here. So and then checks 4, it says yeah. So this algorithm is done now. It's checking, so it checks this part and says this is done. So this algorithm is complete now. And if you look inside this chart, then you're going to see the step of all these numbers coming. So that's the beauty of these algorithms. Very powerful. If you guys looking for a good job, or if you guys looking for a job in like best programming or something, then you guys need to learn this algorithm. So now we coming to bubble sort has a worst case and average complexity of n square. O is big O, that's called big O notation, and that's upper bound. So I don't want to confuse you with upper bound. And n2 is quadratic time, so like x2, x to the power of 2, x to the like O n is linear time, and we're going to see the time complexity here, here, and that's the worst case, is like how long it takes, the maximum time that it takes. That's what we are interesting. So the worst case running time describes the longest running time for any input. Of each input size, it is useful to measure since it captures the program's running time at its worst. So how long it takes, the program takes. Sequential search performs n probes. So n is the number of probes in the worst case. When it fails, the worst case running time is Tn, is T times n is equal to n. So calculating the worst time force running times sometimes is relatively easy, and it's not necessary to consider any legal input, but only some worst case input of each size. Average case running time, this describes the running time average over all inputs of each input size. Now we're going to go here at the worst comparisons. So the worst case here is big O of it's called quadratic time. If you look at inside this quadratic time, this is linear time, this is constant time, quadratic time, quadratic. So we have a quadratic, linear, constant time. We have n log n. So if you look here, best, worst, and average case, that's what I was talking about. This is the best, worst, and average case of any given algorithms. Express what the resource usage is at least, at the most, and on average. So what we are interested on the worst case. We are less interested in the best case, because the worst case tells us the upper bound, and the upper bound, it tells us that how long it's taking. Say if you guys computing something, for example, you are guys interested of how long it is taking. Say if you guys go to Google, okay, Google's opening. Say if I wanna I'm gonna put a merge sort. Okay, so now the Google's bringing this one, and it's telling us that's how many records are found, and 0.58 seconds. So it took 0.58 seconds for the Google to find this merge sort inside the inverted index, inside the Google inverted index. So this is the worst case. That's how it took. So and the Google guy is always interested in this one, so they want to improve this 0.58. so if you go say 0.55, then you improve this worst case. So interested in the upper bound. This is called upper bound. We are coming towards the time. We quickly explain this time, then we start our algorithms here, and we are putting this OF1 is constant time. So that's what because C++ is telling me this this is like a code, but it's not a code. So log n is logarithmic time. So that's logarithmic time, and n, which we saw log O of n, is linear time, and n log n is the best time. N log n is n log n time, and n to the power of 2, it's quadratic time, and n to the power of 3 is cubic time. And that's how we're gonna describe that in asymptotic notation, which I'm gonna make a video. So if you guys interested, just leave comments below, and I'm gonna explain to you guys the asymptotic notation. And we're gonna go ahead on O notation, omega notation, and theta notation. So O notation is the upper bound, omega notation is the lower bound. Theta notation consists of O notation and omega notation can be used together to define classes of function whose growth rate lies between two bounds. I don't want to confuse you guys, so we go ahead with our bubble sort. And with the bubble sort, we go ahead with our algorithm how to see this bubble sort. All right, so this is leftover from our last program. which we find that the minimum and maximum value. We still need this CSTD library, and we come here and we see our we still need these items because of 50, or you can put a 10 or whatever, because we want to do this size 50. And here items, and here instead of minimum maximum value, we're gonna put, say, A or B, our X and Y, A or B. You guys can put anything, X and Y, A and B, doesn't matter. But we still need I for, because we're gonna run our loop. We still need the array of our item. This is our array with the size 50, and that's our size. That's how long our the size of this bubble sort is gonna be. All right, so with this one, we still need this, the size of the total, our total size of bubble sort is. So we're gonna start from 0. I is equal to 0. I is less than the size, which is 50, and I plus plus, and we're gonna put our items, the size of our array items. Sorry, we're gonna run our loop here. Sorry, we are going to run our loop here because I was confused with this here. So we're gonna run our loop. I is less than 50. We increment our I, so our I, we're gonna assign this random function, which is inbuilt function in inside the CSTD library, and we want the 50 items. If you don't include this one, you guys might see a huge number, a huge generated number. So what I'll do is that I'll get rid of this. Okay, so I'll get rid of this because it's a bit confusing. We're going to leave that. Alright, so at the bottom we want to see the size of our array, our bubble sort array, and here the size of the total size of the bubble sort is. Then we're going to run our loop like here, and here we're going to put a 50, but here we are putting say, you can put a size, up to you, and you can put a size here as well because we already define our size and the size, and put a I plus plus and items I, and here, and we put a C out, and we put a line. So that's what our line is. Okay, so now we want to see our array. So now we're checking our original array, which we're going to build our project, and we see if our program's got any error. So this is our original array. What I'll do is that here, because I'm putting an handle, is coming as like this, but build projects, and then we're going to run, and that's how our the numbers. So it's 36, 27. That's the best example, I think, of the bubble sort. We have a huge array of numbers here, but we want to put this here with this line underneath here. So we want to see here, and how do we do that? We are going to put a C out, and we are going to put next line, when we want to put this our numbers, our line underneath. So that's, now it looks all right. So this is our bubble sort, and I'm gonna put this line underneath there, this line here, and I'm gonna put a C out, and I'm gonna put a next one to organize ourselves. Alright, so we run our program again. Now it looks good, so because now we can see our numbers, our a computer generated number, which is 50 items here, and we want to sort this into order, so from 1 to 50. So we're gonna go into action and we see how we're gonna do that. All right, so once we find out our array, and this bubble source gonna be in only 5 to say 10 lines. That's it, no more than 5 to 10 lines. So it's not scary or anything, it's just easy. All right, so we're gonna put a C out, bubble sort, we say bubble sorts in action. All right, we're gonna run our loop. Say we've got a loop here, we already used I, and now we're gonna iterate our loops A and B. All right, so we put a for A, and we're gonna start it from 1. A is less than the size, which is 50, and we're gonna increment A plus plus.